All right, this is the last problem here, and change the numbers, but we've seen a problem like this before. So this is determine the speed of the box at time t equals 0. So x dot, that's a way of writing derivative. So x dot is going to be 4t plus 0.3. And so at time equals 0, that implies that the speed is going to be 0.3 meters per second. Very exciting. All right, now, that's it for that part. Let's take a look at the next part. What is the kinetic energy of the box as a function of t? So let me just go back here. So we have x dot equals, 4t plus 0.3. And do we have a mass? Let's just make sure. The mass of the box is 100 kilograms. So we'll go ahead and use that. So the kinetic energy of the box is going to be 50 times 4t plus 0.3 squared. Excellent. The second part, because again this comes from 1/2 mv squared. And 1/2 of m is 50. And then I'm taking this and squaring it. Net force acting on the box, so F equals ma. So that's going to be x double dot is 4. So I'm getting a force of 400 newtons. And then finally, the power being delivered to the box. That is going to be power. I look up a formula. It's FV. Or if you want, you can take the derivative of the kinetic energy. It doesn't matter. But it's going to be 400 times 4t plus 0.3 for the power. Excellent. So next part, the work done on the box from 0 to 2 seconds. What I would do is this. I would do work is change in kinetic energy. It's much easier. So I have 50 times, if I have this right, 4t plus 0.3 quantity squared. And that's going to be from 0 to 2. So I'm going to get 50 times 0.3 squared minus 50. Got it backwards. 50 times 8.3 squared minus 50 times 0.3 squared. And so the work that I'm going to get done is going to be, I'm getting 3440 joules, so 3,440 joules. Now it turns out the work done by the student would have to be greater than the total work done, because the work total equals the work done by the student minus the work done by the friction. So therefore, work of the student equals the total work plus the work done by the friction, and that ends up being bigger than just the net work done. All right, so then we're going to, whoops, that is a different little thing. So this actually wraps up our free response questions.